It is recording now. So anyway, a transaction database. What would that be, do you think? What's a transaction database? They're all relational databases, but
Like a shopping cart or something.
well, it could be. Shopping is one thing. So yeah, go ahead.
Like a bank.
It could be a bank. Basically, a transaction database is a database that captures transactions in real time, right? So it could be a shopping in the sense of purchasing. So when you go to Amazon and you order something, that would be a transactional database. It's recording the purchase in real time. Banks, as you withdraw and enter things, those are transactional databases. They do things in real time. Some databases, I mean, if you think about some of the really powerful databases, think about your cell phones. There are databases that handle every call, every text, everything you do on your phone is basically handled instantaneously in a transaction database. So one of the things that transaction databases need is that they're optimized, right? They're optimized to be able to do things quickly. They also have to be right. So basically, when you're dealing with a transaction database, you might have thousands of people signed in simultaneously, right? And there are lots of things that you have to be able to do with that. You have to be able to keep them separate from each other. So that each one has to have their own context, right? They need to not step on each other. It can be really difficult. I'm not going to go into all the details of it, but when you get up into an enterprise level database, this is a really important concept. How do you keep many, and in some cases thousands or tens of thousands of simultaneous users happy so that their transactions are proceeding rapidly and fine, and make sure that they don't stomp on each other? It can be a problem. For instance, like in Amazon, it's possible that you could query something that somebody else has just purchased. And it's possible you could purchase something that doesn't exist. It doesn't happen very often. If it does, they apologize or they go find it somewhere else, I think. But concurrent, because if somebody purchased it while you were looking at it, there are some things you can do. Amazon doesn't do this. Amazon does not lock something. If you ever order tickets online, when you're looking at a block of seats, it locks it so nobody else can see those seats while you're looking at them. Generally, retail stores don't do that. The Ticketmaster and all of that does. All of those are different things. I mean, as I said, the main concept here is concurrency. The fact that most databases have a lot of people talking to them at the same time. And transaction databases especially are that way. So they're optimized for speed, and insofar as possible for accuracy. I'm not going to go into this too much, but just there are white papers out there that say you can't do both. You can't have speed and accuracy. You either have speed or accuracy. Amazon goes for speed over accuracy, and other places, sometimes like a bank or something, they might let you hold or hang there for a while for the sake of accuracy. Whereas Amazon just goes for speed. When you think of how many people are accessing Amazon at any one moment, they would get a lot of complaints if your transactions took too long. And if they lock things out, it would slow things down. We'll talk more about that later. But again, those are kind of advanced things. I just want you to know there's a lot of transaction databases. Now we're going to make them, most of the databases that we are going to look at are transaction databases, but they happen at a lesser level. They'll be simpler. These are all relational databases. They're really just different uses, different optimizations. Anybody have another one that might be you could think of? If you don't, that's fine.
An inventory system.
Well, an inventory system could be, all right, so it could be attached to a transaction database, right? because when you're buying and selling, it's coming out of the inventory. It could be a separate system. I still think I'd make a transaction. It just may not be as urgent. You know what I mean? Do you have an idea? What I'm thinking of, and I'm fishing here, I'm not expecting you to know. What?
Okay.
Well, eBay is a transaction they're selling.
But what if you're using database to look at past sales data?
Yes, that's sort of where I'm going. Management information systems. So if the data is real time, and eBay would be real time for the bids and stuff, right? And I didn't spell information right. I have information. There's another use. It's still a relational database. It probably doesn't have a structure much different than the transaction one. But management information systems are databases for basically for analyzing business information. And we'll look at another. These are kind of a more immediate business. There's another level of this which looks at strategic things, but this is more, did we make any money? You know, did our, how many sales did we have in this month? How many did we sell of this product? Look at different regions, how many were sold. And not all databases are business and retail. It could be for data, scientific data, or something like that. But typically what happens with these is that these are not live. They're copied from a transaction database to a database where you can analyze the data. And they're optimized for basically queries. You just want to ask lots of queries. Typing while talking. So, you know, where are our sales? What are our profits and losses? All the business information that a company needs. So if you're doing science, you may just look at what are the, you know, how many examples do we have? I don't know. You'd have to think of the specific science thing, but where they analyze it. They typically are offline in the sense that they're not live because these kinds of queries would slow this down, right? So these are typically, you copy the data from the relational database, and you copy it as often as you need. You might copy it 2-3 times a day, or you might copy it once a month, you know, and then you do your analysis of that. There's no difference. The table structure of these databases may be identical. The main difference is that this one is set up for speed, and this one is set up for query information. Does that make sense? There are some levels beyond this. This is usually when they talk about management information systems, they're usually talking about the stuff you need for quarterly reports, monthly reports, things like that, where you basically say, we sold this much, we made this much money, our costs were this, you know, that kind of thing. But there's another level, and I'm, excuse me, I'm just going to call it business intelligence. Typing is not my forte today. Anybody have an idea what a business intelligence system would be?
So is it like Google Business where it tells you like who visits your page, the demographics, and
Well, there's a bit of that. It's even broader. It's more the way that Google tells you your friends bought this. You know, what ads they put at the top.
yeah, but Google Business doesn't have to do with that. So it just tells you. It just tells you like for example, it tells you like I have a website and I can.
Right,
see
those are
who
just
visits, who visits like different countries.
right, right. This is more like the way Google decides what to put at the top of your search bar, right? In the sense of they do an analysis of you and anybody in your network, and they know everyone in your network through Google. That's what they really wanted Google Plus to do, is to give them the network that they can put. One of the things that actually the results are tailored to you. You know, so you tend to see things that are related to past searches. The problem with that is that particularly when you're searching like political things or that, you only get stuff that sort of supports your own opinions. It helps silo you a little bit. It also, the stuff they put on top and the ads that they put are based on your past searches and things. So it's basically they're analyzing all of your past searches, and then they know a little bit about your demographics. So they will also do research across demographics. I mean, it's scary what Google knows about you. It's scary what a lot of companies know about you. Yeah.
So, I mean, that sounds like it would be much more the sort of big data.
It is. This is a little bit more big data. This is the big data thing. The way that Amazon says other people that, bought this also bought this. So it is big data. It doesn't have to be big data. I mean, that's becoming more and more common. And we'll talk later more about the big data. It could be on a business level. If you take all of your customer information, all of your sale information, all the information that you have from the transaction and things, where you're looking for things not as specific as how much money did we make in this quarter, but you're looking at things like trends. What is something growing in sales? Is there a particular demographic that is being drawn to our sales? It can help them guide advertising. It can help them guide product placement. Where they're not looking for specific things, they're looking for patterns, any kind of pattern, right? Patterns that they can use against you, basically. Things to sell you stuff. Or, I mean, on the other side of that, it's what the government does with big data when when they want all the phone records. They're looking for patterns. They're looking for patterns of people that call the Middle East a lot, which is a problem if you're like a Middle East reporter or something. They're looking for, just any kind of pattern. They have a list of things that they consider suspicious, and they look for those patterns across vast reams of data. So business intelligence is basically a database set up with those tools for doing statistical analysis. We're not going to go there this quarter, but the business intelligence may have all the data from the transaction database, but typically they are rearranged. The structure of a business intelligence database is typically different than the regular relational database. And again, they're structured for queries, but for those statistical queries. So these are kind of the big data, looking for trends. And they're structured. Structure and by is, see if I can remember these. My brain just went blank. And there's measures. And the other thing is descriptions of the measures, but there's a word for that. So the measures are called facts. That's what they are. There are fact tables and there are dimension tables. I knew it'd come back eventually. And we're not going to worry about that much. But the dimensions are basically things that describe the facts. Facts are things you can add, subtract, multiply, divide, basically.
So hard to get.
Yeah. Well, so a wage, for instance, if you're looking at business, it could be a fact because it's that, and then the dimension would be the position, for that wage, or the company, things like that describe where that wage is, the context for it. Again, we're not going to do that, although there's big money here. I mean, if you really wanted to go into database, if you can get the data analytics, if you can get it involves knowing statistics. Yeah.
What about user registration? Where would that fit in? Would that be MySQL or any of those?
So the user registration for like what? For like the
Just the site.
So when you register for a site, that would be, I would consider that more like of a transaction database. Now they're keeping track of you, so it could go through all three. I mean, so when you actually do the registration, it would be a transaction database. When the company underneath looks at how many people are registered and you know, what your actions, how often you use the site and stuff like that. That might be management information system. They may also do some business intelligence, and he wants you to register, is that they, even if they aren't doing this themselves, they can sell their lists of customers to people that do this. So I would probably put it on the transactions. Like when you go to a site to register, it goes into the main transaction database. As to whether it's MySQL or that depends. It could be any database software. Other questions? As I said, this is more just for your information. We're going to focus mostly on the transactional because it's actually the simplest to do. We'll do a little bit of this in the sense that we'll do some queries, but we won't make it a whole separate database, which is, yeah.
The second one is like SAP, that's the
Say again.
SAP, the software.
SAP, yeah, so SAP is a set of tools.
Like, so that's a very focused on the second one.
Yeah, I think it is mainly focused on the second one. There are commercial things on all these levels, so we're going to make them from scratch, but there are transactional databases you can buy. There are different manufacturers. So like if you're, I know the dentists. If you're a dentist, there is database software pre-developed for dental offices that you could use and for handle all the x-rays and things like that. There's, you know, one of the things we'll build is an apartment management thing. I'm pretty sure that there's pre-built databases for apartment management stuff. So a lot of these exist. There are different management information systems. Most of them are customizable to some extent. There's a lot of these, and some of these go into, and I won't go into this too much more, into the NoSQL databases, which when you get into them, you might be surprised that they often have a lot of SQL. But somebody said it's not NoSQL, it's not only SQL. Because they do, in the business intelligence, they try to analyze structured relational data with things like memos and documents and feeds, things like that.
So I was wondering about this yesterday. I looked it up, but Amazon, I guess they have this database system they developed called DynamoDB that's like a key value. It's not a relational database, it's a key value thing.
There's a lot of things. Do they use it online, I wonder?
I think, yeah, it's supposed to be part of like the AWS thing, but it's supposed to be like really large, scalable.
There's a lot of, we're going to look at a relational database. There's a lot of experiments right now. The key value things, again, one of the problems with them, so I think that their main transactional database is still Oracle. But there's a lot of experimentation with like JSON, which is just a key value thing. Mostly because of speed. And one of the things that has happened recently is that relational databases are really powerful and really accurate. And it used to be that the brute methods that they use for a lot, like the key value methods and the just analyzing text, were too expensive in terms of time. But processors have gotten so good that you can just do something by brute force rather than subtlety. And sometimes it works as well. So, but they're not as accurate. A lot of the databases that are NoSQL do not promise you exact results. They promise you a range of results. So
That would fall under the business.
yeah, yeah. And I don't know about the Amazon one. I know that Facebook developed their own non-relational database also, mostly for the big data analysis. And again, it doesn't return exact answers, but it's really there to look at trends and patterns.
Well, yeah, I mean, if you're looking at business intelligence, you don't need exact answers.
Right, you just need trends.
Picture,
Yeah.
trends, you need forecasting.
So, and SQL Server, if you buy the full version, has this stuff built into it. And Oracle has tools for it too. So, but there are also a lot of other things out there, which we'll look at later. So this is just sort of background information. Are there other questions? There are obviously other, kinds of uses. One that we really aren't going into is artificial intelligence to some extent. And then artificial intelligence is basically a big database with a set of questions. So if you think about how a computer does artificial intelligence, it basically says, it's like asking 20 questions. So each question eliminates other possibilities. So before a computer makes a decision, it looks at the data and it looks at the probabilities and it just keeps asking questions until it's come down to a few possibilities. Yeah.
Definitely in artificial intelligence, who will be like Cortana system?
Cortana system, yeah. So Cortana, so it does a match on database that it has, right? So when you say a word, it looks for that word. And it also does what they call heuristics, a set of questions to eliminate, to try to get down to the possibilities that are most relevant. So because a computer has no mind, typically if you just ask a computer a question, it'll give you the most bizarre answer because it doesn't know what makes sense and what doesn't make sense. So the programmers have gone in there and set up a set of questions that it goes through, and with each one, and it works off a database because the database gives it percentages and probabilities for its answer. An example of this, and I don't want to go into it too much, although it's fun. They actually are using them a lot in doctors now, right? So if you type in your symptoms, what that does is it goes through the database and it eliminates anything that doesn't have those symptoms. Basically, that's it. So if you say you have a cough, it'll eliminate everything that doesn't have a cough. If you say you have a fever, it'll eliminate everything that doesn't have a fever. And what it does is it comes down and in the end delivers a handful, 2 or 3 or 4 or 5 possibilities given the symptoms that you've entered. Doctors use those mostly because what the computer will do that the doctor won't do, because the doctors are trained the same way. If you go to a doctor, they ask you a series of questions. Each question is meant to eliminate certain possibilities, and then you get down to a few. The thing is that the computer will bring up the exotic possibilities that a doctor wouldn't because they've never had an experience of them, like a tropical disease or something. And once in a while, that's the right answer. Not very often, but.
They did that here in Washington. They had a computer and a doctor, and the computer was more accurate than the doctor.
Yeah.
40-something% of the times. And so there was an article about in the future, like in 10 years, there will be more nurses than doctors because computers will be artificial intelligence will be doing the job of doctors.
I've noticed at Group Health, they have their computer, and it essentially is doing that. I mean, the doctor's free to disregard it, but.
We're never going to eliminate doctors unless we have massive healthcare system overhaul. Well, so the reason we're never going to get rid of doctors legally, the only person who's allowed to prescribe the medication is a physician.
Yep, I agree with that.
So we're never going to fully get rid of doctors, but yeah.
Can't a nurse practitioner prescribe?
Yes,
Yeah,
they're the only other ones, but that's because they have their degree program is one step below a PhD or a medical degree. I mean,
medical degree.
The MD, it's this far away, really. But yeah.
And machines are, they're good, but they're not
Foolproof.
They're not foolproof. I think there actually will always be a good tool. Somebody, usually, because they usually come up with 3 or 4 decisions at the end. And somebody has to decide which is the more likely, So, although, a doctor, and this is true like with the chess machines and all of that, again, this is all extra stuff. The thing that a doctor can't do that a machine can is no doctor could have the range of memory that database gives to a machine, right? The chess machine human chess players are smarter, but the chess playing computer has a list of every game ever played and the probabilities of every move given every configuration. So, you know, and they can get through it. As I said, computers aren't very smart, but they're very fast. And they can get through, you know, whereas a human could probably process 10 or 15 main games that they've seen, you know, in a few seconds. The computer can go through tens of thousands of possibilities and measure their odds in that time. And those are all database driven. And actually, I'll just mention one other thing. The cloud itself is database driven. So if you go to, you know, if you have a Microsoft account, you have OneDrive, and you have those. If you have the Google account, you have the Google Drive. If you have Dropbox, you're storing things elsewhere. The cloud is basically just services that are offered through the internet. Where they exist, boxes of computers in warehouses in places like Moses Lake because their energy is cheap. Although I think it was Google just built one in Scandinavia under the permafrost because one of the problems is heat from all those machines. And basically what they have underneath databases keeping track of where everybody's stuff is, all those machines. So the whole cloud is based on machines. They typically copy everything 5 or 10 times so that if any one machine dies, it's not an issue. Right? And they buy cheap machines. You'd think they'd buy good ones, but they buy the cheapest crap they can. And because it's cheaper to put in a new box than it is to repair something. So the cloud is essentially driven on databases. And you can, if you want, and then I will move on. You can get an Amazon cloud account, for instance, for pennies. You can go to Amazon and say, I want a Linux box with Apache. You can even say you want a Windows box with Apache, PHP, and MySQL. I want it to be this big, and you can have it in seconds. They charge you by bandwidth. So if only you are using it, it stays pennies. But if you suddenly get popular, it can cost a fortune. Microsoft has Azure, which one of these days I'd like to teach. They charge differently. They have a base fee plus bandwidth. So, you know, so there's you can, and you can create a SQL server up in the cloud and they'll monitor it for you. It has the advantage that they back it up. They do all those kinds of things. It's cheaper for a company to put things in a cloud, but they typically don't at this point for security reasons. One of the things they do for the cloud is like a retail company. Typically their business volume around Christmas is 5 times what it would be the rest of the year, or maybe more than that. What they often do is they will buy cloud space for the data for the holiday. They'll process all of that. When the holiday's over, they'll bring it all back down and then close out their cloud accounts because it's cheaper to put it on the cloud at that point than to buy the infrastructure you would need for the peak times and only use it at Christmas. Right? So, okay, so that's a lot of stuff about database. Just the kind of the environment. Any questions on that? Because we're going to step way back to something more like what we're going to do. Building this kind of infrastructure for, as I said, like the cloud and stuff too, involves a lot of not only database skills, but networking skills. There's a lot of networking in there too. Okay, so why do people create a new database? This is stepping back, and let's think of a smaller scale now. Why does a company or person or something decide they finally need a database? Yeah.
Need something that's smaller than file cabinets. It takes up less room.
That's true. So it might be just to,
Or they have too much data to keep in a room full of file cabinets.
yeah. I'm just gonna say make paper electronic. Yeah, type. If all of your things are on paper, there's lots of problems with having your files on paper. One is room. One is that it's really hard to do an analysis when you have paper. You basically have to pull all the paper out and count things. So moving to an electronic thing. The other thing you said is sometimes even if you've been keeping it on spreadsheets, this is real common. A lot of small businesses in particular, and even some fairly large businesses, have kept all of their data on spreadsheets. Spreadsheets work really well up to a certain threshold. Basically when you start, if your business needs are small, if you're running your own little cafe or something, you may not ever need more than a spreadsheet. But as the data gets bigger and bigger, you find that it's outgrowing the spreadsheets, not only just for the sheer number of rows, but because it's such a pain to figure out what's going on, right, from all the spreadsheets.
Well, like I've heard from people that work at Boeing that Boeing is still largely run on spreadsheets, basically, that they just like tons of, that's kind of their.
Boeing is a weird company, actually, if you ever worked there, IT-wise. They have mainframes from long ago that they still use. They have Access databases, Microsoft Access databases, and then they have SQL Server databases, and they have spreadsheets. They've never, I guess because they're so big and it would be so expensive, they've never actually integrated it all. Their technology goes from the super sophisticated to the fairly old-fashioned and primitive, which actually is another place has a huge potential if you have the skills as hospitals. They're in a similar kind of thing. They have the most sophisticated tools in the world oftentimes, but they've never made them talk to each other. They often have their records on paper, but they also have all these optical scanners and stuff. So there's a huge opportunity in medicine for building databases. In fact, a few students have done it. The problem with going there is that you usually have to understand the medicine, to do the databases. So one of them is get the paper. If your spreadsheets at a certain point tend to get, you tend to outgrow them. What other reasons you might have a new business, of course, where you want to track the data. Any other things that you can think of? Reasons why somebody would want to start a new database. Did you have an idea?
Inventory management, forecasting.
Right, so you might want to get a better sense of inventory and forecasting. I've known quite a few small business operators, my daughter among them. She runs a cafe. I really doubt that she knows whether she's ever made any money. She's making enough to cover, supplies and wages, but I don't know that she's ever analyzed what it cost her to do business versus what she's taking in.
In fact, that means she's successful.
Well, she hasn't gone bankrupt yet.
It's kind of the definition of small business.
Yeah.
Unfortunately.
She doesn't pay herself a wage, but occasionally takes money out, which I think is an accounting error. Might even be criminal, I'm not sure. But to get a better control over that, you might want, inventory and forecasting. In general, basically, there's, in abstract, either the old system doesn't work anymore, whatever that old system was. So basically, maybe you would keeping track. You could even have a database that's existing, but it's not sufficient. The business needs have changed. You're doing things that you weren't doing when you first created the database. Software has advanced to give you more features. So it doesn't work anymore. The other reason might be to take advantage of new features. And abilities. You know, just because to keep you competitive, you know. If your neighbors are being able to do this kind of thing, they'd like to do it too.
You may need it because of the new abilities. Your guys that are providing you with your raw materials may use it.
Right. You might need to do it. You might need to do it for, how would we do it? Compatibility? Yeah, compatibility and integration. It's not apartments. You know, basically, people typically do not do a database unless there's some need to do it. One of the things you'll find if you go out there is that businesses hold on to their old database well beyond their useful life. Because the data is in there, they don't want to change. If they change, I mean, there's a risk in change. But at a certain point, it becomes so cumbersome that you have to change it. You have to add it, you know, upgrade your database systems, make new databases. I had a call, it was a year or two ago, from a business that had all their data in DBase. Does anybody remember DBase? It's a DOS-based database system. It's a long time ago. They had all their business data in that database, and the person that ran it died. Nobody knew how to get in. So but I mean, this was only a couple of years ago. To have a DOS-based database system that long is weird. It's also a very bad idea to have only one person that can do anything.
There's still stores that have their POS systems on DOS.
Yes,
So,
and the school is still running a COBOL database on a mainframe, Unix mainframe. So.
oh,
Partially because it's just too hard to transfer. It's too much data. And it's not just one school, it's 33 community colleges sharing it. Okay, so how do you start? So what I wanted to mention, I mean, there's usually a history. When you go into a situation where you're going to build a new database, there's usually a history, and that history involves what they've done in the past, and why are they needing a new database, right? So basically, they could say we've kept everything on the Vincent one we're going to do. They kept everything in a spiral notebook, but that's getting way out of hand. So they need a database or something to track, as you mentioned, the inventory, and to get a sense of what they're spending versus what they're selling. You know, so, you know, another thing, there might be a scientific database where they, you know, they need to track, you know, materials from a new grant or something. I would like to, there are a couple of science databases we could download, but I don't think we will this quarter. NOAA has all the weather information for the last 120 years. So you could get all the rainfalls and all of that. But it's a kind of boring, and it's actually in a comma delimited file, so you have to make it into a database. So there's usually a history, which is sort of the backstory about why there's a need for a new database. Now, I didn't ask you, you don't have to buy this book, but if you look at the databases in here, particularly in the first chapter, it goes through like a brief history of why this is, you know, each database is required. The next thing that we need to do, and this is where our assignments actually start. Let me break this line. Is you want to create kind of a scope for the new database. What do you think a scope would include? Anybody have any idea?
what they want it to do.
Right. It's basically, what does the database need to do? These are weird little things, and there's a couple of things you may, if you ever work on these, you might be part of a group or people that come up with the scope, or they might just give you the scope. But one of the things about the scope is it should be general. And what I mean by that is that it shouldn't include things like we're going to do it on SQL Server or MS Access. It shouldn't include what the table structure is going to be. It shouldn't include what the security model is going to be. I mean, it doesn't. It should be more general. It should be kind of high-level requirements. So let's think. Yeah.
So it's not the same as the architecture.
It's not the architecture. Yeah, it should be independent of the architecture. So when we think about the scope of, let's think of, think about the cell phone one. How would you describe what the cell phone database would have to do? We'll just write a quick, so
It's be fast.
it does need to be
It
fast.
needs to be lightweight.
How would it need to be lightweight?
Well, because people usually have pretty limited, you know, I mean, I guess nowadays phones have a lot of horsepower, but.
But it won't, this phone, this won't be on the phone.
Oh,
I mean, it's basically probably a computer warehouse somewhere.
Yeah. Way to identify everybody inside the database. It's simple.
So it needs to track,
Track them somehow.
it needs to track users, right? So it needs to know the user information, which is, we don't need to worry about this now, but it'd probably be based on their cell phone. Accounts, right? Because everybody's going to have a different kind of accounts.
Man, like who's your cell phone carrier?
That and maybe contracts too. I'm thinking this would, probably every carrier has their own database.
Data usage, like how much they have left.
Right, so it's going to have to track the data usage. It's going to have to track calls, right? It's going to have to track all the calls from and to, basically, who the calls, let's make it English. So it needs to track users, accounts, contracts, the data usage, and the data usage would be based on, and it not only does it need to track calls, it needs to track text, right? Text.
so then, I mean, does it need to track like their social media? Their tweets and stuff like
I don't know if it needs to track that. It just needs to know what data is coming through. You know, I don't think the phone company cares whether your data comes from Tumblr or Facebook. It's just the data that they're charging for. Facebook cares, Tumblr cares, but I don't think the phone company cares. Is there anything else that it needs to do?
Commissions,
What?
who has an open account and who doesn't.
So accounts.
Billing.
So they need to shut it off.
Right. Now I'm thinking that the billing, all right, so I might track billing. I might actually make a different database for billing. But the contract should say what you're allowed for data usage and what you're allowed for time and things like that. The contract should have those limits. I probably on this level would make a separate database for billing based on that. It would take the data from this one and use it for billing. One of the things about a database is it should be about one thing, right? All the things related to one thing. So we'd have a transaction database, which is basically about all the, all the things that it needs to track. So right now we don't have a lot. It needs to be fast. It needs to track users, accounts, and contracts. One of the things that it needs probably is it's going to have to store an enormous amount of information, right? So it needs to be capable of
for 1,000 people at the same time.
Right. Right. So would it go into terabytes or they go into petabytes?
Probably Vita.
Is that how you spell peta?
It needs to be scalable, right? Because you need different times, there's gonna be different numbers of users. We don't want all these systems.
Yeah. So how many? Or just thousands of simultaneous users?
It's like AT&T for the millions, right?
Yeah, we're limiting our. And so that's the concurrency, right? Lots of information and simultaneous users. It's a peak tolerant. So there's other things that this would be. This is a much higher level. I mean, much more sophisticated database than we would be. The point that I want to make about it, though, is that we're just talking about the requirements in general, not the specifics. We're not talking about the hardware. We're not talking about the software. We're not talking about the structure of the database. We are just talking about the high-level requirements. It needs to store these things, right? And again, you don't need to get into detail. You don't need to get into what about contracts does it need to store. It just needs to store contract information. The next stage after you've figured out these general things is to get into the specifics. But you don't want to start with the specifics. You don't want to start with a preconceived notion of what the hardware requirements are going to be, what the software requirements. Those should come from analysis, not from pre-setting, prejudices. Like this, obviously it's going to be have to be a very capable database system, but you shouldn't decide ahead of time if that's going to be SQL Server or Oracle or Postgres. I don't know that I'd use MySQL with this, but you don't need to decide that ahead of time. You look at the requirements when you get into the specific requirements, and then you make your decision on hardware and stuff. Now, sometimes the decision's pre-made for you because it has to fit their existing systems. But does that make sense, though? And a statement of scope can be larger than this. It also can do things that are, you can sometimes put, things that it won't do. Like this database won't do billing. Billing will be a separate. Part of the reason that I didn't delete everything, did I? Let's go back. What did I just do? All right, let's undo what I did. I just wanted to do enter there, and that made everything go away again. Why is it making everything? I did undo. I have no idea why it's doing it. Yeah, close the header and footer. Not sure how I got there. Now it's in the header and footer for sure, though, isn't it? Did I move all this to the header? Yep. Anyway, billing, you can put constraints on it too, things that you want to. One of the reasons you want this is a really important thing, because when you build the database, in the end, you can go back and say, does it do these things? Right? Even though these are fairly general, they're really a good, is your database doing what it said it would do? Is it fast? So you can test it, right? Can it handle that many users? You can test that. Does it store the information for those things? You can say yes or no, right? Is it doing those things? Is it scalable? Is it peak tolerant? And you can test those things and say, does it do those things? So the statement of scope is what you measure the end product against. Does it do the things you said it was going to do? And again, it doesn't have to be specific about software or product information. It's just specific about what the general requirements of it are. I have no idea how I put that all in heading. Well, I'll fix it later. So our assignments, let's see if I can get into that. Ooh, that's big.
Seahawks 1, 2, 3?
What?
Seahawks 1, 2, 3?
No. All right, that was for the last class. Oh, no, I don't want to do that. Let me in again. Close. Courses. 220. Okay, so let's look at assignments.
Your resolution's so big you can't see it.
Yeah, if this is probably still, let's do the minuses a little, because we've set the, how's that? Is that too small?
That's good.
Okay. Now, we'll look at a couple of things. So the very first assignment is really easy for the individual assignment. It gives some examples of scope and asks you to choose which is the better one and why. All right. And you can turn it in with a text box this way, or you can link it to a Google Doc or something, or you can upload a Word file or something. So whatever. This is, as I said, is really simple. It's just a couple of examples of a scope and asking which one is better and why. So the other thing that we need to do or get started on is down here where we do groups. The group one is going to write a scope for the Vince's thing. And I've given a brief description of that, and we can talk about what the scope might involve. But this is a group assignment. So one of the things I'd like to do is sort of start dividing you into groups. And ideally, a group should only be like 3 or 4 people. In the past, it was, we did all the different databases, but this time you're all going to do the same one. The end result doesn't have to be exactly the same. It depends. You decide certain things. I'm not going to make you stay in these groups the whole quarter. We'll do Vince in a group, and then we'll do the apartment database in a group. So you aren't totally consigned. Do you want me to do groups where I would basically just number you out, or do you want to choose your own groups? You want me to do it? All right.
Should we do it the people sitting next to each other?
That's what I was going to do, is just basically count out 3 and 3, and 3 which goes around the corner, and 3 and 3. That actually works out pretty well. 3 and 3, I guess you would go with the 2 over there, and then 3 and then 3. That actually works out very well. Do you have any idea of who I said? So, a couple of things that I want you to do real quickly is send me either an email or an announcement or a discussion as to who's in your group, because I just did it by pointing and who's in your group, basically. Just the names of the people in your group, and then you can start working on the scope, and I'll help you with that And then basically for the rest of the group stuff, what we're going to do, once you're done with the scope, and scope is enough to get started on that today, then we will look at the requirements and business rules, and then we'll diagram the database. So there's a lot, I'll have to talk about those things more. And then later, and I don't know if it'll be the same groups, we can decide that. The dates will change if that's true. We're going to build the database, and then we'll test it, put some data in it and test it. So for now, though, just give me an email or something to let me know who's in your group. And then we'll work on the scope. And if you need more information on scopes, I have, actually what I don't want is home, I want syllabus. In the syllabus from last time, there's a blog. So it'd probably be near the front of the blog. So there's like a statement of work for, there are a few statements of work in there from the examples, right? I think actually if you search this, which would be better, just statements of work. Maybe just add a statement. And it comes to, it gives you several examples of statements of work and scope.
What section is this under?
This is the blog. If you go to the syllabus, there's a link to the blog. You don't have to, I'm not making you guys write a history. The examples all have a history and they have objectives and a timeline. I'm just going to have you guys write a scope. Just what the database will be about. The example of the database for this group too is the Vince's vinyl, which you can get a fuller description from in the book. But basically, Vince is a person who runs a used vinyl shop. Okay, so there are things about used vinyl. Every record is going to be unique because they're in different conditions and things. He has kept all of his records in a notebook. He tends to be overly generous and not too organized. So he will, you know, he's really not sure that he's selling things for any more than he paid for them.
So he would go out of business.
He could, yes. So basically the database is to help him not go out of business. All right, so I'll let you guys get to know each other. You should make contact how you guys want to work together.
What is your email address?
So my email address is it, you can also just email me in the Canvas, but do you need that bigger? It's Stephen.Conger at seattlecolleges.edu.
Okay.
I did enjoy it.
So what I did, at the top of the syllabus is a little link to the blog. And then at the top of the blog, I did a search for a statement of work or statement of scope. I think either one will work.
Oh, the blog right here. And then you search on statement.
We still have it in stock.
Is there something about the group project on the syllabus? I missed it on that.
So it's not so much in the syllabus as in the, yeah, so it's under assignments.
Because I was wondering why that was too long.
Yeah, so this is for the vinyl store. Couple things too, maybe even though I want you to kind of do the statement of scope, maybe don't turn it in right away because I really would like to enter the groups. So then you only have to enter one, right, for the group. Do them, but don't upload them yet, and I'll have them ready for Canvas uploads.
I just sent you an email.
That's fine. If I get you grouped, you only need to upload one for the group.
Upload one assignment.
Well, yeah, for the group.
Oh, I see.
But if I don't get the group set before we start posting, then I could probably figure it out, but it'll be individual.
So just to be clear, individual scope project.
There's an individual scope project, and then there's a group one.
Okay, and the group one is due also the same.
Yeah, and they're not due. I think I can get them as next week.
Okay.
I think you'll be done before then. And again, the dates are not super important.
So I would say each.
I know it's a little confusing. It starts chaotic, it gets better. If you do upload the scope, it's not a bad thing. I'll figure it out.
A couple of fields for it. Condition of the record, condition of its cover. Each one of those things.
Oh, sure.
Also lowers its price. Yeah, and then probably the title, like the record.
Go syllabus there. And then, do you need it bigger? Can you see it?
Final condition and cover condition.
So Steve, just to clarify, the statement of work that you have on your blog, is that what our assignment should look like?
It doesn't have to be that. I'm just asking you to do the scope.
Just the scope, so it says no paragraph.
Yeah.
Okay.
Yeah.
So this is so much.
Right, yeah.
Right, so basically what I want is the team members, and then you guys can work on writing that statement of scope for the business body. And then there's the individual assignment where I just ask you which is better and why.
Yeah.
Not the whole quarter, but maybe about a half. Yes, I want the names for the group, yeah. Email or you can do a discussion or so on campus you could do a discussion or an announcement, or you can just send me an email. My email address is right there. I might be able to set up the groups right now if I have enough.
Just to clarify, is that the Oh, okay. Okay, I was thinking about the campus.
I know.
Okay. Okay.
So the big final.
Okay.
Record store is also big.
Okay.
And you need to store album as an individual
Find all of
item.
us.
Yeah.
That's why instead of like saying, okay, you know,
His name for you. That way we can find each other.
the Steely Dan album, each individual piece of my database. But like, as opposed to, let's say I have 10 copies of a record, so the title is database items, each individual. So
That'll be fine.
Physical item. Each physical album to be. That's how I read it. Okay, let me go back to, I'm going back and forth on this one.
Individual album.
Oh, yeah.
Oh, sorry. Okay, so. Some of the albums with a lot, with Panama artists, the physically not. Yeah, the title artists.
You're going to create it?
Quality. Oh, the physical quality.
I suppose it's possible you could make your own groups. That's
It's a good question. So,
okay. That'll work too.
and the companies to say that.
Also, ask each other questions at this point.
The difference between albums to.
You know, hey,
So the price, if you have, yeah, so the price that,
might not be interested.
so say